Hello everyone, welcome to another video on nodal analysis. In previous video, I had a brief discussion on the concept of supernode. If you haven't checked that video, you can check by clicking on the link which is provided in the description box. Now let's apply that concept of supernode for solving different numerical problems. The first problem is in the network shown in figure. Find the voltage V1, V2 and V3. So which means the different node voltages are already known to us. The network is consisting of different sources and resistances. This one is V1, this one is V2 and this one is V3. So basically the nodes are already specified to us, node voltages are already marked. We don't need to identify that how many nodes are there in the circuit, and we don't need to assign the voltage to them. It's already there in the problem. So we are already provided with the nodes and their respective voltages. We need to apply KCL to all nodes. So our first step is apply KCL to node 1. When we apply KCL to node 1, there are 3 branches connected to node 1, 4 ampere source, 0.33 ohm resistance and 0.5 ohm resistance. We know the direction of current because we have a 4 ampere source connected in this branch, so it's moving towards the node. We don't know the direction of current through 0.33 ohm, so I'm assuming this one is outgoing. Same for 0.5 ohm resistance. So when we apply KCL, 4 ampere current, it should be equal to V1 minus V2 upon 0.33, which is the current through 0.33 ohm resistance. V1 minus V2, that is potential difference divided by resistance, plus current through this 0.5 ohm resistance is V1 minus V3 by 0.5. So this will become 3 times V1 minus V2 plus 2 times V1 minus V3, and simplification of this will give us equation 5V1 minus 3V2 minus 2V3 equal to 4, which is our first equation. So then next step is we have to apply KCL to node 2. When we apply KCL to node 2, again we will mark the direction of currents through each branch as outgoing, since we don't know the direction of current. We can write the current through this 0.33 ohm resistance as V2 minus V1 upon 0.33. Current through 0.2 ohm resistance as V2 minus 0 by 0.2. But when we come across this branch, here we have a voltage source of 5 volts. We don't have any resistance in series with this voltage source, so we can't write the current in this branch. Same is the problem when we move on to node 3. So what we need to do, we need to combine node 2 and node 3 to form a supernode, and then we will write the equations One will be by applying KCL and second will be the constraint equation which we actually get by KVL. So we write this one as outgoing current. We will also write this current as outgoing current. So next step is combine node 2 and node 3 to form a supernode and apply KCL at supernode. So when we apply KCL, current through this branch is V2 minus V1 upon 0.33, V2 minus V1 upon 0.33. Then next is the 0.2 ohm resistance connected to second node. So it's V2 minus 0 by 0.2. Then we don't need to write the current through 5-volt source. We can move on to the remaining branches which are connected to node 3. So that is 1 ohm resistance and 0.15 resistance. Current through 1 ohm resistance is V3 by 1. So plus V3 by 1. And then current through 0.5 ohm resistance is V3 minus V1 by 0.5. And this should be equal to 0. So this one becomes 3 times V2 minus V1 plus 5 times V2 plus V3 plus 2 times V3 minus V1 equal to 0, and simplification will lead to our second equation, which is 5 minus 5V1 plus 8V2 plus 3V3 equal to 0. This is second equation. Third equation will be a constraint equation. That is a constraint imposed by this voltage source. Now 5-volt source positive terminal is connected to node 3. Its negative is connected with node 2. It means node 3 is at higher potential as compared to node 2. V3 minus V2 should be equal to 5. So this will be the third equation. So the question was to find out the 3 different voltages. When we solve these 3 equations simultaneously, V1 comes out to be 2.633 volts, V2 minus 0.167 volts, V3 is 4.833 volts. Let's take one more problem to have more experience on supernode. Next is find the current through 4 ohm resistance using nodal analysis. Here we have a 2 ampere source in series with 2 ohm resistance, again 2 ohm resistance in series with 6-volt source. Here we have 2-volt source, 3 ohm resistance in series with 3 ampere source. This is a given network where we need to find out the current through this 4 ohm resistance using nodal analysis. So first step over here is we need to identify that how many nodes are there where we can apply KCL. This is first node, second node, third node, and we have another fourth node which I will consider as reference. Now let's assign the voltage to each node with respect to reference V1, V2 and V3. The next step is we have to apply KCL to each node. Let's start with applying KCL at node 1. So current through this branch is 2 ampere since we have a 2 ampere source connected in this branch and current is flowing away from the node 1. We don't know the direction of current through this 2 ohm resistance. I am assuming this one as outgoing and current through this 2 ohm resistance as well outgoing. So the equation after applying KCL is 2, that is current in this branch, plus V1 minus 6 minus V2 by 2, that is potential difference divided by resistance, plus current in this branch is V1 minus 0 by 2 equal to 0. So this will give us the equation 2V1 minus V2 equal to 2. That is our first equation. Now when we move on to next node, we can write the current through this. We have the current in this branch 3 amperes which is flowing towards node 2. But when we move on to this branch where we have a 2 volt source, we can't write the current because we don't know the resistance of this branch and we can't consider it as 0. So we need to combine node 2 and 3 to make a supernode. So node 2 and node 3, they are combined to form supernode and we have to apply KCL at supernode. Apply KCL to supernode. So when we apply KCL to supernode, 3 ampere current is incoming to node 2. Assuming the current through this 2 ohm resistance leaving node 2, 3 should be equal to V2 minus of 6 since negative sign is coming from this side minus V1 by 2. Then moving to node 3, we don't need to write the current through this as it's not possible. Then at node 3, let's assume current through R4 as outgoing plus V3 by 4. Now current in this branch, that is 2 ampere and it's flowing towards node 3, so it is an incoming current, so it will be added with 3 amperes. So what we have in this, the simplification of this will give us minus 2V1 plus 2V2 plus V3 equal to 8, which is our second equation. Third equation is the constraint imposed by this voltage source. Now what is the constraint? Constraint is the potential difference between these two nodes should be equal to 2. As positive terminal of this voltage source is connected with node 2, negative with node 3, so it means node 2 is at higher potential in comparison to node 3. So constraint equation is V2 minus V3 should be equal to 2. This is the third equation. Now we have to find out the current through 4 ohm resistance. For that we need the value of V3. So let's find out the value of all the voltages, the simultaneous solution of these three equations will give us the value V1 as 4 volts, V2 6 volts, V3 4 volts. Current through 4 ohm resistance, I4 ohm, it's V3 minus 0 by 4. So it's V3 minus 0 by 4, 4 by 4, it's 1 ampere. Let's consider one more problem to have more insight on the supernode concept, and that will be the last problem for supernode analysis. The problem is find the power delivered by 5 ampere current source using nodal analysis. The circuit is having a voltage source of 10 volts, and then we have 2 ampere source over here, 5 ampere over here, and different resistances. So as we have to find out the power supplied by this 5 ampere source, it means we need to find out the voltage across this 5 ampere source, and when we multiplied that voltage with 5, that will give us the value of power supplied by this source. For finding out that voltage, we need to apply nodal analysis as it is mentioned in the problem. So let's identify that how many nodes are there. So the first node, where we have interconnection of 3 elements, 10 volt source, 2 ampere source, and 3 ohm resistance. Then we have another node, let's consider this one as second. Here we have interconnection of 4 elements, and this one is third node, where we have interconnection of 3 resistances. This one is fourth, 1 2 3 4 elements connected. Let's mark this one as reference. Let's assign the voltage to this node as V1, to this as V2, and V3 to third node. Now apply KCL to each node. So what we can say, power supplied by 5 ampere source is 5 into voltage across this. What is the voltage? V2 minus 0. It is equal to 5 into V2. So basically we are interested in finding out V2. So when we apply KCL to node 1, we can write the current in this branch, current in this branch, but we have the problem for finding out the current in the branch where we have a 10 volt source. Again the problem is same, we don't know the resistance of this branch. Same problem with node 2. So we need to combine these two nodes together to make a supernode. So node 1 and node 2, they are combined to form supernode, and then apply KCL at supernode. So when we apply KCL at supernode, current in this branch is 2 ampere, which is leaving first node, so it's an outgoing current. So 2, let's assume the current in this branch as well, outgoing, so it's V1 minus V3 by 3 plus V1 minus V3 by 3. Then moving on to the branches which are connected to node 2, we have 1 ohm resistance. Let's consider the current in this branch as well, outgoing with respect to node 2. So it's V2 minus V3 by 1. V2 minus V3 by 1. 5 ampere current is incoming current. So it will be equal to 5. Then current in this branch I'm considering again as outgoing. So it's V2 minus 0 by 5 plus V2 minus 0 by 5. So when we solve this equation, then we have 5v1 plus 18v2 minus 20v3 equal to 45. First equation. Second is the constraint equation. The constraint imposed by this 10 volt source is v1 minus v2 should be equal to 10. Why v1 minus v2? Because positive terminal of this 10 volt source is connected with node 1 and negative with node 2. It means node 1 is at higher potential in comparison to node 2. So the constraint equation is v1 minus v2 should be equal to 10. The second equation. Then third equation is of node 3. Next step is we need to apply KCL to node 3. So there are 3 resistances connected to node 3. As again, since we don't know the direction of current, let's assume that all the currents are leaving node 3. So current through 2 ohm resistance is V3 by 2. Current through 3 ohm resistance is V3 minus V1 by 3. And then we have last resistance 1 ohm, which is connected between third and second node. So it's V3 minus V2 by 1 should be equal to 0. Simplification of this equation will lead to minus 2V1 minus 6V2 plus 11V3 equal to 0. This is third equation. So when we solve these 3 equations simultaneously, first, second and third, V1 comes out to be 13.7 volts, V2 is 3.71 volts, V3 is 4.52 volt. So the question was to find out the power supplied by 5 ampere source, which is equal to 5 into V2. So P 5 ampere is 5 into V2, 5 into 3.71, 18.55 watts. I hope these 3 numericals are helpful to you for understanding the concept of supernode, and you can apply in the coming problems. In next video, I will consider the application of nodal analysis to the circuits where we have dependent sources.